Okay, so far we have seen functions and you understood, right? What is a function? So, Banu, what a function does? Like, why we are going with functions? Why we need functions?
If we can, so if, if you want to any call function, we cannot write like again and again. So when we can use function, when we want to fetch the data, we can once call that function, the data will be fetched automatically.
Okay, so basically, function it will increase, like it will what you say, assist us with reusability as well as it makes code modular. Okay, we can modularize the code, which will help us in debugging, and also it increases reusability. Can kind of reuse the same code just by calling the function instead of writing same code repeatedly. Okay, so when we are having function, it is kind of named one. We are naming a function and we are creating it. We are giving some identity to the function. Okay. So when it comes to lambdas, these are anonymous. Okay, these are anonymous or nameless functions. We don't do like we are kind of don't have any names. We don't have any definition. Let's say if we need to do very small task, we don't need function for that. Okay, we can directly use this lambda function and we can perform our task in that on the go. And as soon as task is completed, this function will be flushed out of memory. Okay. So basically, function is a named one. We'll be defining it and we'll be using it throughout. When it comes to lambdas, this is a nameless and anonymous. There won't be any state, any name, or anything. We'll just use it, and once we are done with this, the function will be flushed out from memory. Okay, we'll be creating them on the go while writing our code. Let's say we need to perform some task using some logic, so we can just write this like a nameless function using lambda, and we can achieve that. As soon as that line is executed, we won't be having that function again with us. Okay, so how syntax will be here? Like syntax will be lambda. Lambda is a keyword. Okay. If you are giving this lambda keyword, this tells interpreter that this is a lambda function. And you'll be passing arguments. You can pass a single argument or you can pass multiple arguments. Okay. Lambda arguments, and this is the colon which will separate our arguments from our logic, which we need to do. Okay. These are arguments and this is expression. It is nothing but which we are like what we are trying to do using that lambda. Okay. You see the example, this lambda x colon x square. So this function, what it will do, this is just creating a function which will accept an input and it will return a square of the input. Okay. Will just accept the input and it will return a square of the input. So for calling these sort of functions, if we need to individually call lambda, we have to assign it to some variable. Okay. Now we are assigning it to sq and this will become a function, lambda function. And when we call this sq with some integer or any value, then this will return a square of that number. Okay. So ideally, we won't be using this lambda in this way. Okay. I'll show you in the later slides how we really use this lambda and why it's very powerful. Okay. Same. We can also use some conditionals as well. You see here lambda x, even if x percentage equal to 0, else odd. What this function will do, it will print even if provided number is x. It will print odd if it's not even. Okay. Let me, so let's say I have function square where I'm giving lambda x x square, right? And if I'm calling it using some value, will give me the square of this number. This is the basic lambda usage. Okay. Let me, I think it's initializing. So we have some built-in methods which are filter, map, and reduce. Okay. When we use this lambda with those functions in combination with those filter, map, and reduce, this will become kind of more powerful. That's the actual usage. Like why we are intending to use lambda, we'll be using it in combination with filter, map, and reduce. Okay, this is very least used thing, like taking lambda and assigning it to some this thing. Okay, this is used in some what you say non-typical scenarios. In very special scenarios, there will be some few scenarios where we might want to use function in this way. Okay, so I'll be having one more function. It will check for even or odd. Okay, lambda x, and it will check if it's even or not. If x percentile 2 equal to 0, then this will be even. Okay, just remember this is the condition. It will check for this condition. If this condition is true, this will be returned. Okay, if this condition is false, then this will be returned. You see, even of 10. You can see even of 9 will display odd. This is how conditionals work. Okay, can also pass multiple parameters. Okay, if I say x is equal to 7, right? X comma y z comma z is equal to 7 comma 8 comma 9, right? I have three arguments here, right? I have three arguments here, right? So if you see lambda x comma y comma z, I am giving x plus y plus z. You see, okay, I think this is just making the function. It's not actually calling the function. Okay, I am assigning it to some variable and I need to call it with x comma y comma z. Okay, you see, it will take 7, 8, 9, and it will use sum of these numbers. Okay, can perform any sort of change. This can perform any sort of changes here, operation. So it will take arguments and it will give me the result of this. Okay, this is the basic usage how function lambda function works. Okay, this is how lambda works. As I said, this will be more powerful and more useful when we are clubbing it with filter, map, and reduce. Okay, ఈ system బయట వేసుకొస్తాం. So what these functions filter, map, and reduce functions will take, they will take a function and a sequence. Okay, this filter, map, and reduce will take a function and sequence and applies the function to all items of the sequence. Okay, let's say we have one list of 5 items, 5 numbers from 1 to 5. What this functions filter, map, reduce functions will take, this will take list as well as a function. Let's say we have a function which will square the numbers. It will take input and it will return square of the number. So it will take function list with 5 numbers and function, and it will apply that function to each and every item. So now in the list, it will convert, it will take all the items in the list and it will return squares of that list. Okay. So I'll show how this is used. Okay. Now filter. Our very first function is filter. Okay. What filter will do? It will take sequence of items and a function. It will take sequence of items and a function, and it will apply filtering logic. It will apply filtering logic and it will return only items from that sequence which are satisfying this condition. Okay, clear, right? It will take a sequence and function and it will apply that function to this list. Okay, and function will be kind of making some comparisons. Function will be making some comparisons. Okay, and only things which are satisfying these comparisons, those will be returned. To see the example, the syntax will be filter of function comma list. Okay, this will be the function. This will be list. It might be anything, list or sequence or tuple or set. It may be anything. string. It can even be string. Okay. And if you see here, I have taken one list which is having numbers from 1 to 20, right? And if you see here, what this will do, filter of lambda. Like this, my first part here is function, right? This is my function. What this lambda is doing, lambda x, it is taking one input and it is checking whether it is even or not. Based on that, it will return true or false. This x percentage x modulo to equal to 0 will provide us true or false. Okay. Only things which are true that will be returned by this lambda function. So it is just checking whether a number is even or not. And this we are passing this list. This list has 20 items. It will check all these 20 items and it will provide us output. Even this output will be iterable object. Okay. The output given by this filter function will be iterable, which contains only items which are satisfying the condition. Only items which satisfy the condition which we have given through function, those will be returned by the filter, and this will be iterable. Okay. Let's practically do this. Let's say I have taken one list which is ls and I have list of range of 50. Okay. I have numbers from 1 to 50 in this list. And I wanted to filter what I am trying to filter here. Lambda x, x percentile 5 equal to 0. Okay. I am trying to filter all the multiples of 5, number 5. All the numbers which are perfectly multiples of 5, I wanted to take only those numbers. Okay. From where I am taking them? From this list ls. From this list, I wanted to take all the numbers which are perfect multiples of 5. Okay. And I'm just executing this. Sorry, some syntax error. You see here, this is a iterable. Okay, this is a iterable. Iterable in the sense we can kind of iterate through that. This is a iterable, and you have seen this generators, right? I have told about, I haven't covered about generators and right. So okay, when I cover about generators, you will come to know how iterables will work. Okay. So let's say I can do any sort of thing here for number in filter print number comma end is equal to, let's say, one tab, or let's say, you see here initially we got some filter function kind of thing. Now what I did, I have iterated through this iterable which is written by this filter, and I'm printing them, right? So one more way to use this is here, our ultimate aim here is to take list of items and create a new list which contains only multiples of 5 between 50 and 1 to 50. Since 50 like end range is exclusive, it didn't consider that 50. Now I made it 51. So ultimately it will consider 50 as well here, right? If I print this now, you can see initial list I have numbers from 1 to 50. After applying this filter, it has filtered only items which are multiples of 5. Clear, right? This is how filter works. And then map. So map, what map does here, as name suggests, map will map things. Okay. It will take some functions and it will map that function. Like it will map the objects of a iterable, objects of a sequence to this function. So map is nothing but it will transform. Okay. It will take a sequence and a function which will be basically transformation function, and it will return a new list by applying the transformations. Okay, it will apply transformations and it will return us the new list. Okay, so same syntax will be same. similar to the filter. Syntax will be map of function comma iterable. Okay. We'll be passing one function and one sequence here. To see the example, I have a list with me which contains numbers 1 to 5. And from this list, I need to create a new list which will be the square of just a second. Okay, so we are taking a list and we need to the result we need to obtain a new list which will be the square of numbers. Okay, that is 1 2 3 4 5 and list like new list should contain square of each number. If you see here, what I did same as filter. List of map of lambda x square. So this is my function. This is my lambda function which will take a number and return square of the number. And I am applying this to ls, which is my sequence. And the resulting list will contain 1, 4, 9, 16, and 25. Okay. So this is my built-in function square. If I need to apply some other function apart from lambda, let's say I have this map function. This map function will take a number, and what this will do, this will divide a number by 2, and it will multiply it with 40, and then it will add number 2. So it will take a number and it will perform this operation, this mathematical operation on that. Okay. And same I can do list of map func comma ls. So let me practically show this. Okay. So I have ls which contains numbers 10 comma 20 comma 25 comma 30 comma 40. So these are my numbers. So I need to obtain a new list which contains lambda x, which contains numbers like half the numbers which are in original list. Should half the numbers from the list and it should return me a new list. Okay. So for this, I am taking this lambda function, which will take a input and it will divide it by 2 and it will provide me the result. Okay. And I'm giving the list, which is my sequence. You can see it just divided each and every number from this list by 2 and it returned us the new list. Okay. Same thing. Let me take this function. We have this map function, right? I'm taking my func and it will take one number. And the result of this number will be n divided by 2 into 10 plus 5. So it will take a number, will divide it by 2, and then it will multiply it with 10, and then it will add 5, and it will return us the number. Okay, if I take my func of 2, you see 2 by 2, 1, right? 1 into 10, 10. 10 plus 5, 15. So it's returning me value of 15 here. So now I can apply this function on my list. Okay, list of map of my func, comma, my list, which is ls. You can see, right? Here we are not giving any lambda because we have our own function. Lambda itself is a function, but here we have our custom function. So we don't need that lambda because we are already having function with us and we are just passing that function. So what map will do? Map will take this function and it will pass each item from this list. Will pass each item from this list to this function and it will take result and it will store it in the new iterable. Clear, right? And these are the same things. We can pass any number of items, any number of arguments. Okay. So you see here, I have list 1 and I have list 2. And what I am doing, list map of lambda x comma y x into y. So I am taking two lists and the third list will be the multiplication of these lists. So it will take first item from this list and first item from this list, and it will multiply. Same, second item, it will multiply 2 with 3, 3 with 4, 4 with 5, 5 with 6. Okay. If you see here, we have only 5 numbers here. Here we have 6 numbers, right? Since list 1 has only 5 numbers, it will consider only 5 numbers from list 2 as well. If you have any extra numbers, it will just ignore them. Now the resulting output will be only 5 numbers which are kind of multiples of these things. Okay. Let me do that practically. Have ls1 which contains 1, 2, 3, 4, 5, right? ls2. No, eight items here. Then I am doing, I wanted a new list which will be taking items, 2 numbers, and it will return me multiplication of them, right? Is taking 2 numbers and it is just returning me multiplication of 2 numbers, product of 2 numbers. Okay. And I am passing 2 lists here instead of 1. Okay. I am passing 2 lists here. If I execute this now, you can see 2 into 1, 2. 3 2s are 6, 4 3s are 12, 5 4s are 20, 6 5s are 30. It's just ignored this 7 and 8. I'm giving 7 and 8 here. Let's say I'm giving 7, 8, 9. You see here, it will consider only this. It will consider equivalence. And if there are any extra items, it will just ignore them. This way, you can kind of perform operations on 2 different sequences as well, like multiplication, subtraction, any sort of things. Okay. And then reduce. So reduce is, as name suggests, it will take a list and it will reduce it. So reduce is kind of mathematical technique. So in mathematics, we have a technique which is folding or reduction. Let's say we have one cloth or paper with us. So what folding implies? We are just folding it. We have this much of paper and we are folding it and we are making it very small piece of paper. Similarly, in mathematics, it will take a sequence and it will fold it. It will fold it. While folding, it will apply some operation. So you have seen this cumulative product during our high school or even during our engineering. So what cumulative sum will do? It will start from first number. We'll take 1, 2, let's say we have 1, 2, 3, 4, 5. What cumulative sum will do? We'll do 1 plus 2 plus 3 plus 4 plus 5. And result will be the addition of all these numbers. Cumulative in the sense group. Cumulatively, it is taking them and it is performing reduction. Initially, we have 5 numbers. After performing this folding, uh, it will get only one number, which will be sum of these 5 numbers. Can be product, can be some subtraction, it can be division, anything will happen. This technique is called folding or reduction. We are taking a sequence and we are reducing it. We are reducing it. If you see here, this reduce, this function and the map are readily available for us. Those are inbuilt keywords. But the reduce, this is part of func_tools library. Okay. We'll be having one func_tools. I'll explain this when we are talking about packages and libraries. Okay. So we need to import it. We need to import it and then we'll be using it. So in our program, first we'll import func_tools library, and from func_tools library, within that func_tools library, we have this reduce method. We'll use that reduce method in our function, in our program. Okay. So if you see the usage in this slide, what I am doing from func_tools library, import reduce. I am asking my interpreter to import this func_tools, like import this reduce method from my func_tools library. After taking that, I am calling this reduce. The syntax of this reduce will be reduce of function comma iterable, which is sequence, and then initializer. So initializer, what is initializer? I'll show you. Okay, when I am talking about the example. Let's say we have list 1, 2, 3, 4, 5, right? What I am doing, I am reducing this list using lambda function. So what lambda function is doing, it is taking two numbers x comma y and it is performing multiplication product. So now how, and it is, we are passing our list to this reduce function. So now how this reduce works, we'll take this list, this will be my x, this will be my y, right? It will take x comma y and it product of these two will be 2, x into y, x comma y 2, right? Now my x will be 2 and my y will be 3. Product of 2 and 3 will be 6. 6, right? Now my 6 will be x. X will be 6 and y will be 4. 6 into 4, 24. Now at very final, my x will be 24 and y will be 5. And my final result will be 120. Right? So with each and every step, it is reducing. It will multiply, it will throw away the two numbers and it will have single result. It will take that single result and it will multiply or perform operation with next number of the sequence and it will throw away these two numbers. So it will kind of reduces the sequence. You see the initializer, we can always start with the initializer. Okay. Now here I have given 2. So while performing this reduction, initially it will consider x to be 2. Instead of this 1 here, it will consider 2 as the first element, first item. It will multiply 2 with 2. 2 into 2 will become 4. And then 4 3s are 12. 12 4 is a 48. 48 5 is a 240. So when I am passing 2 as initializer, this result of this will be double of this. Since I am initializing the folding like folding operation from 2. I am giving 3 here, then it will be triple of this, which will be 360. Clear, right? This is kind of optional. We can pass. We won't use initializer much, but just remember that we can also initialize value like with which we need to perform this reduction or folding. Okay, let's see this practically now. Let's say I'm taking the same list which contains these numbers, and before proceeding, I need to import this. Right, I am doing from func tools import reduce. I am importing the reduce method. I am just reducing. And in reduce, what I am doing, I am passing a function which will be lambda x, and it is adding. Okay, sorry, x comma y, and it is adding them. And I am passing my iterable, which is my ls. You see here, we will take all these numbers and it will add this number with this again result with this. It is kind of giving me the cumulative sum. We add all these numbers, the result will be this only. Okay. So when we say sum of list, you might have seen right that sum method in list while covering list. Sum of list. So sum of list that under the hood at the back end it will be performing same reduce operation, and we are getting that result. There, right? Filter will, as name suggests, will filter the items from sequence. Map will apply transformations to the items. And reduce will reduce a sequence into single number based on the operations which we are doing. So when we are using this lambda with these functions, so it will be kind of more powerful. Okay. So this is the lambda and this filter map and reduce. How we can use them with filter map and reduce. Okay. So there are few examples. You can see this, right? With this reduce, I can also pass my custom function as well. So here I have you have seen this lambda xy is equal to x star y, x product y, right? Same thing I have did here. I have a function named prod. It is taking two items and it is returning me product. In this reduce, instead of having my lambda function, I am just passing my product function. This itself is a function, and I am passing sequence, and the result will be It will apply this product function to this sequence one by one, and it will reduce this, and it will give me result of 120, right? Same thing here. I have one more function which is having min value. It will take minimum value of both things. Okay. To see, and it will return me A if A less than B, else B. It will take two numbers and it will reduce me the minimum number, minimum value of both. If you see here, what I am trying to do here, I am taking a list. Let me take this list. Okay, I have this list, right? I'm having one function which is minval, and it is taking two numbers which are a comma b. It is returning me return a if a less than b, else b. Okay, the function will just return the minimum number from both. Okay, now I am applying this on my function. Okay, reduce of sorry, reduce, and I'm passing this min val comma my ls. You can see it will just give me the minimum. It can be in any order. Okay, I can have 1 and 0 as well here. Okay, and my reduce operation will give me the smallest number from this list. Okay, if we are not using this and if we follow the conventional way to find minimum number, what we have to do here? If you see here, I have this minval comma rest is equal to numbers. Okay, I'm taking the very first number from the list and the rest of the elements into different list. And for each number in this list, I'm comparing it with my minimum value. Minimum value, let's say I have taken one as my, let me show here. We have this list right with us, which is having 2, 3, 5. So if I'm not using reduce and I'm using my normal Python logic with for and if loops, how I can do? You see here, minval comma star numbers is equal to ls. What I'm doing here, I'm taking the very first number. If you see this minval, this will be my number 2. And numbers will be containing all the other numbers apart from 2. Right? So for each numbering, for numbing numbers, I'm comparing them with my minimum value. If min val greater than number, okay, or else if number less than min val, what I'm doing, I'm taking each and every number from this list and I'm checking if it is less than my minimum value or not. If it is less than minimum value, my minimum value will be nothing but number, right? Because initially we thought 2 will be our smallest number. After iterating through, it will go till this point, right? And then we have 1. 1 will be less than minimum value. So it will assign uh, this 1 to this minimum value. Now again it will go to 0. 0 is my minimum value. So now it will take this 0 as my minimum value. And I can print my min value here. Okay. It should be num. You see, I need this many steps. I need to initialize this. I need to have a for loop. I need to have a if loop, and I need to call this. So this 4 lines of code, 5 lines of code, we can perform in a single operation using this reduce, right? Clear, right? This is the one which we used to do so far, but with reduce operation, we can do this same here. Can also apply this lambda function instead of this min val here. We take lambda x comma y x if x less than y else y. Okay. I can also perform same operation here using lambda. Instead of taking this function, I can have a single lambda which will take two numbers and it will return smallest number. and I'm applying this on my sequence, and it will give me the lowest number here. Clear, right? So this is the basic usage of lambda and filter, map, and reduce. Okay. So I think we are good for now. It's already 6:20. So we'll cover the rest of the things in tomorrow's class. Okay. Tomorrow I'll be talking about generators and decorators, which are kind of again extensions to our functions only. These are also part of functions, but these are extensions too. And then we'll cover modules, and then we'll go with the other rest of the things, object oriented programming. Okay. So clear, right? Clear with today's concepts. I'll be sharing this slide deck and you can go through them and you can practice. Okay.